Alright, so in today's video we're going to talk about solving systems of equations with inverse matrices. So first, I want us to take a note that a system of linear equations can be written as a matrix equation. For example, if we have the system of equations ax plus by equals e and cx plus dy equals f, in matrix equation form this can be written as a coefficient matrix A, B, C, D that we multiply by a column matrix X, Y and set equal to another column matrix E, F. We can also say, or set some stuff up. If we let A equal that coefficient matrix, A, B, C, D, we let this capital letter X equal our XY matrix, and we can let the capital letter B equal the EF matrix. We can then say that A times X is equal to B. Matrix A times matrix X is equal to matrix B. Now, we can use the matrix operations to get X by itself. We can take AX equals B and apply the inverse matrix of A to both sides. In fact, I'm going to rewrite the right side here. I'm going to erase B. Now, if we multiply A by its inverse, we're going to get an identity matrix times X equals the inverse of matrix A times B. And the identity matrix times X is just going to be X equals the inverse matrix of A times B. So we can therefore say that if we can set this up, X is equal to the inverse matrix of A times B. So now I'm going to write down some steps for solving systems with inverse matrices. So our steps to solve a system with inverse matrices is as follows. We're going to first write the system as the matrix equation AX equals B. Then we're going to find the inverse of matrix A, which we can also call the inverse of the coefficient matrix. And then lastly, we're going to multiply the inverse matrix of A by the constants matrix, which we've called B. So we can get that matrix X is equal to the inverse matrix of A times matrix B. So let's look at some examples. And I'm going to need more space, so I'm going to go to a new screen. Example 1, we're going to look at the system 7x plus 5y equals negative 14 and negative 6x plus y equals negative 25. So first, we write the system as a matrix equation. So we're going to, in step 1, write out first the coefficient matrix, 7, 5, negative 6, 1, times xy equals negative 14 times negative, not times, sorry, and then just negative 25. So now we need to find, if you remember the steps for finding the inverse, we need to find the determinant of matrix A. So we find the determinant, we go 7 times 1 minus 5 times negative 6. Well, 7 times 1 is 7. 5 times negative 6 is negative 30. So we're going to add 30 to 7 and get 37. So now all we're going to do is we're going to, if you remember, to find the inverse matrix, we take the determinant 1 over the determinant of A, and we multiply it by the matrix A. In fact, let me rephrase that. We switch A and D, so we're going to go 1 and 7 get switched, and then we take the opposites of B and C. So we take negative 5 and positive 6. Now we can replace that determinant of A with 37. So we're going to multiply everything by 1/37 in there. So our inverse matrix of A is going to be 1 over 37, negative 5 over 37, 6 over 37, and 7 over 37. So now to find our solution, to find x, so this was step 2, we just finished. For step 3, we're going to take our inverse matrix and multiply it by b. So we're going to take our, in fact, I'm not even going to write a new thing. All I'm going to do is I'm going to write my negative 14 and my negative 25 right next to it, so I can just keep my work going. So now I'm going times b. This step is happening here now. So we're going to go the first, I'm going to go 1/37 times negative 14, which is going to give me negative 14/37, plus negative 5/37 times negative 25. So that's going to give me 125 over 37. Now I do the second row times that. So 6 times negative 14 gives me negative 84/37, plus 7 times negative 25 gives me negative 175/37. And now I can actually add them. So negative 14 plus 125 is going to give me negative 111 And if I divide that by 37, that's going to give me negative 3. Negative 84 plus negative 175 gives me 259 over 37, which simplifies to 7. So I found my solution. My solution is negative 3, 7, which means as an ordered pair, it's going to be x is negative 3, y is 7. Let's do a couple more examples. So example 2, we have the system 12x plus 11y equals negative 35, and negative 8x minus 5y equals 21. So step 1, I'm going to write this as a matrix equation. I'm going to have 12, 11, negative 8, negative 5 times xy equals negative 35, 21. Now I'm going to find the inverse of my coefficient matrix. So I'm going to first find the determinant of that matrix. So I'm going to go 12 times negative 5, which is negative 60, minus negative 8 times 11. So I'm going to actually change this to plus 88, which gives us a determinant of 28. So we're going to go A inverse is equal to 1 over 28 times, we switch our A and D, so negative 5 and 12 switch places, and then we take the opposite of the other two numbers. So we make this 8 and negative 11. So we're going to have negative 5 over 28 and negative 11 over 28. And then we're going to have 8 over 28, which we can actually simplify that one. Divide by 4, we'll get 2 over 7. And then 12 over 28, which again we can divide by 4, so we'll get 3 over 7. So we've got our inverse matrix. Now we can find A inverse times B. So we're going to take that inverse matrix, which I'm not going to rewrite it again. I'm just going to put my B next to it. So negative 35 and 21. And now we're going to multiply. So we're going to go negative 5 over 28 times negative 35, which we can simplify to be 25 over 4. And then we're going to add to that negative 11 over 28 times negative 35. So we're going to have 55 over 4. And then down below, in fact, before I move on, I did make one mistake. I multiplied the wrong things. I want to take my negative 11 over 28 and multiply it by 21, which simplified will give me negative 33 over 4. Now I take my second row and I multiply it by my negative 35 and 21. So 2/7 times negative 35 would simplify to give us negative 10 plus 3/7 times 21 simplifies to give us 9. Now we add them. So we're going to have, what? 25 plus negative 33 is 8 over 4. And that simplifies to negative 2. And then negative 10 plus 9 is negative 1. So we've got our x and our y values. So our solution to the system is going to be negative 2, negative 1. Let's look at one more example, and then we're going to also look at some 3-variable systems, but they'll probably be in another video. So example 3, we're going to have the system 6x plus 8y equals negative 16, and 5x plus 3y equals negative 28. So we're going to first write it as an equation matrix. So we're going to have 6, 8, that 8 looks like a 0, let me rewrite that, and 5, 3 times xy equals negative 16, negative 28. Now we're going to find our A inverse. So to do that, we need to first find the determinant of A. So we're going to go 6 times 3, 18, minus 5 times 8, 40. And we're going to get negative 22. So for our inverse matrix, we're going to go negative 1 over 22 times, first switch 6 and 3, so 3 and 6 switch positions. We take the opposite of 8 and the opposite of 5. So now let's multiply out. We're going to have, for our inverse matrix, negative 3 over 22. And positive, I'm going to simplify dividing by 2. We'd get 4 over 11 for that 8 times 1/22. Then we're going to have 5 over 22. And then again, I'm going to divide by 2, so I'm going to end up with a negative 3 over 11. So now we're going to find A inverse times B, which I'm just going to rewrite my B down here. So I'm going to take my first row and multiply it first by the negative 16 and the negative 28. 3 over 22 times negative 16 can simplify and give us 24 over 11 plus 4 elevenths times 28, which gives us negative 112 over 11. And then 5 22nds times 16 can simplify to 40 over 11. In fact, negative 40 over 11. Plus negative 3 elevenths times 28 gives us 84 elevenths. And now we can combine everything. So if we combine 24 and negative 112, we get negative 88. If we divide that by 11, we're going to get negative 8. And if we combine negative 40 and 84, it's going to give us negative 44. In fact, this is positive 44. If we divide that by 11, we get 4. So our solution to this system is going to be the ordered pair, negative 8, 4. So we'll look at 3-variable systems, the last 3 examples on our note sheet, in our next video.